Let's take a look at 1.7 tables and graphs, where we're going to try and take a set of data and organize it in very specific ways. First of all, some definitions here. Data are information facts or numbers that describe something of interest. Now, it may sound weird because too many people use that word incorrectly. The word data is plural. Okay, so when I've written here data are information, not data is, this is the correct way. If we want to, say, get information from Fenwick graduates 10 years down the road, how much money are you making? What's your income? Um, those would be numbers that would describe something of interest to the people at Fenwick and how well are alumni doing. One way that we can organize data is with the bar graph. Now, again, if all we have is a list of the numbers, the data will not show us anything clearly. A bar graph we're going to use a series of rectangles to show data once we have things arranged in groups. Now, bar graph, we could have things arranged by year. Um, that's a fairly common one. Off to the side here, just a generic example I found. Suppose we asked a whole bunch of people, do you prefer this or this? Giving them a choice of different flavors: chocolate, strawberry, vanilla. So we record all of that data and then we can show that here in a bar graph. And again, sometimes if the data set is fairly small, yeah, sometimes we can tell just by looking at the data set itself. But bar graphs are a way of, as you can see here, it's a series of rectangles. It's showing us the information from the data, but it's in a very easy to understand way. Okay, another way that we could take data and arrange it is by drawing a series of segments connecting data points. So we're going to plot individual points from the data, and then basically we're going to play connect the dots. Okay. Here's an example of a line graph that I found earlier um, from the Axios website based on Nielsen values, numbers, data collected between September 2021 and February of 2023, looking at total TV consumption. What's the source? Okay. So in this case, we have individual data points, and you can see the individual little segments here that in this month of this year, it was, 39% of people were watching cable television, and 29% of people were getting it from streaming. And then again, showing here as time goes on how cable's decreasing, streaming has been increasing, but recently dropped off, broadcast, and then other. Okay, so again, it's a visual way. It doesn't matter if we're talking about line graph or a bar graph here. It's a way of showing the data in a way that's informative. All right, so let's take a look at example number one here. Um, Going back a little bit, going with their numbers here, the table gives the media consumer spending, dollars per person per year in the US. We're being asked to make a table showing the total media spending for newspapers, magazines, books, and television. Okay. Um, so we start with adding the amounts. Now, again, the directions here, let's be careful. Total media spending for newspapers, magazines, and books. So basically, they gave us too much information. We're going to ignore this row entirely. Okay. Then what we're going to do is we're going to start adding things together. So if we take the 5284 and the 3951 and add the 7268, that gives us a total in 1996 of $165.03. Now, with all of this data here, maybe it's clear to you, maybe it's not so clear to somebody else. We're trying to figure out, in what year did Americans spend the most? Well, we're going to have to do some more addition here before we can answer that question and be sure of it. So if I add together the numbers from 1997, the 5281, 4033, 7226, that'll give us $165.40. So it's up a little bit, but not by much. For the next year, and the next, and the last column in our data set. So, okay, the fact that it went up from 96 to 97, really not all that surprising. Things tend to get more expensive as time goes on. Then it went up for 1998, it went up for 1999, and oh, well, that's kind of surprising. There was actually a drop there for the next year. So, to answer the question, in what year did Americans spend the most? Our answer here is going to be in 1999 is when they spent the most on average. If you scroll down to example number 2, here's the bar graph showing the amount Americans spent for cable and satellite television in a given year. So just that row that we basically ignored in the first one. It appears that Americans spent twice as much in 2000 as compared to 1996. Well, where are they getting that idea? So if I take a line here from 1996, oh, let's see if we can do it this way. See if it shows up. It actually cooperates. So it would appear at first that, okay, the amount here and the amount here for this 2000, it's almost doubled because we have this much of it that's above that line. Okay, it looks like this red line that I'm attempting to put in here. And yeah, come on. It looks like this rectangle here for the year 2000 has just about been cut in half. But wait a minute. What's going on here? Explain why the graph may be misleading. Now, to show the difference from one year to the next, to show that things are clearly increasing as we're going along here, they've decided to shorten up the graph by having this little break. And that's what that little zigzag line is doing right there, is showing you that from here to here it's 20. Here it's 20. After a certain point, those horizontal lines on the graph are evenly spaced. But right here, no, that's a distance of $100 per person where they skipped. So again, I would say the bar graph could be misleading because the scale shown on the left side has a break. In the numbering. So as a result, the graph itself does not show the entire rectangles for this bar graph. If all of those were drawn with a consistent scale all the way on down to 0, well, okay, it clearly shows that in 2000 they spent more than they did in 1996, but it wouldn't look like it's twice as much. So they're asking you in this one to draw a new bar graph that would not be misleading. So we're supposed to be able to, I don't know, I guess. Let's go back and look at that first line there. 1996, it's $138.96. If we're redrawing it here, oh goodness, it says amount in dollars per person. But you'll notice there aren't numbers anymore. What are we supposed to do here? We go back up to this. Everything here goes from, say, 138 up to less than 200. So if we want to draw this so it's consistent, let's label this as 200. Now I need to look at, I have 1, 2, 3, 4, 5 spaces to get all the way on down to 0. So if I take 200 and divide it by 5, that means each of these is going to be $40. So this is $40, this is $80, this is $120, this is $160, and then that top one is 200. So this hopefully is not going to be misleading because we're going all the way from 0 up to 200, and each one of those spaces represents the exact same difference in dollar amounts. Okay, so now that I've chosen a scale, let's estimate 138.96. Well, that's going to be impossible to put that. I'm going to try now. See, that's why I don't like OneNote. So this is 120. That would be 140, about halfway in between. So maybe like that. Sorry. For the next one, I need 153. And again, I'm going with shapes, trying to find a rectangle. But again, it's OneNote, so things are going to just kind of jump on its own here. And again, I want to show that it's a little bit taller, that it has gone up. So for the second one there, 153 rather than 138. And then 165. So that's a little bit more than 160. Okay, so I've got that labeled as 160, 165. And then just a little bit less than 180. So, boom, boom. So 180 would be about halfway in between the 160 and 120. And then for the last one, it's 192.82. So just a little bit less than 200. Now again, if I were not using OneNote, which has a mind of its own, trying to make it easier for me to draw these rectangles, and in the end, it makes it harder. We're trying to represent the data here so that we can compare. the width of each of these rectangles, if we're drawing these maybe not on OneNote, those should be the same. The width of those rectangles has absolutely no meaning whatsoever. So we would try to make them consistent. But I had a really hard time with OneNote using these rectangles they started down at the bottom. All right, so that's a bar graph, a bar chart, sometimes called. Let's talk about line graphs. For example, number 3, in 1994, 2001, the average amount spent per student in the United States in public elementary and secondaries, that's you guys, is given in the table. Draw a line graph of the data. Okay, so we're going to do here. They've helped us out that down at the bottom, we already have year labeled. Over here, we already have the amount labeled. Now, first step here is to put some dots on the graph. So 1994, it's $5,996 per student across the United States. Now this, again, pay attention here, it says measured in thousands of dollars. So that's just a little bit short of $6,000 per student. So I'm going to put a point there. 1995, it went up to 6,208. You're going to have to estimate this. There's no way that you can put that in there and be completely accurate. 6,443, just a little bit less than halfway in between 6 and 7. 6764, 7142, 7533, about halfway between 7 and 8. 7885 and 8194. So we put those in as individual dots, and then we do our best to play connect the dots. Now again, I'm only going to draw from here to here. I'm not going to try and draw this as one thing all the way through. I'm going to go from point to point to point. Okay. So again, if it's done professionally, maybe done with a computer, go back to the example I showed you here. It's not one curve, it's a whole sequence there of individual little segments. Okay, hopefully that makes sense. If you could open up the document there from chapter 1, your questions from 1-7 start on, I'm sorry, again, it's a typo. I don't have everything perfect on this. It's page 45, not page 54. So 1-7 starts on page 45. Do your best to answer those questions for next class.